All right. Okay, so we're going to start today with lecture 2, which is trigonometry and vectors. So hopefully you have all already completed lecture 1, which was all about solving equations, right? So lecture 1 was about solving equations and unit conversions. And now we're moving on to lecture 2, which is trigonometry. So we're doing some basic math that you would have done grade 10, and maybe a little bit of, like, if you took vectors and calculus, then a bit of that too. But it's mostly grade 10 stuff, right? So we're going to be using Pythagorean Theorem, going over SOHCAHTOA. We're going to use inverse trig ratios to find the angles in a triangle. Then we'll talk about vectors, how to decompose them into their x and y components, and then how to add vectors. Okay, so these are all skills you need for this course. So it's kind of like getting you ready to begin physics. Okay, so I'm going to have my chat open on my other computer so I can see if chats come up. And yeah, if you carry over your marks, you won't have to do your labs and attend them. That's right. Okay, but you have to make sure you fill out a form, and the form is posted in Canvas. And yesterday's asynchronous lecture is lecture 1. That's right. Okay, so lecture 1 is posted on Canvas. I know it's a little bit confusing. I wanted everyone to write their test together on Wednesday, and I want lecture 1 to be completed before this synchronous lecture, lecture 2. So you complete it on your own. Hopefully you have time to like watch the video and actually complete the questions with me as I'm doing them. And then also you want to be able to do the homework questions. So as many of those questions as you need to feel comfortable, and then you're ready to go to lecture 2. And then on Wednesday, next week, you're going to be writing a test on lecture 1 and 2. So this content, so the unit conversion, solving equations, vectors, and trigonometry, all of that will be on test 1, okay, the week 1 test. And it will be the same format as the bonus, where some of the questions you're just entering your answer, but they're numerical answers, so you'll put in your numerical answer. And then other questions, it will ask you for your answer, but also for your written solution. So at the end, you'll take a photo and upload it as a PDF. Okay, repeating what's on test 1. It's all the content from lecture 1 and lecture 2. So lecture 1 was the asynchronous one that you're doing on your own. It should have been done before this lecture, and it's on unit conversions and solving equations. And lecture 2, trigonometry and vectors. Those 4 topics are all on test 1. Okay, so lecture 1 and 2 are on test 1. Lecture 3 and 4 are on test 2. Lecture 5 and 6 are on test 3, and so forth. Okay, Verena?
Yeah, for test 2, is it just going to be lecture 3 and 4 or 1, 2, 3, 4?
Well, okay. I mean, it's technically on 3, 4, but in order to do certain things in 3, 4, you need to know how to convert units, for example, or how to solve an equation. So like the skills build on each other, but the focus is on 3, 4.
Okay, thank you.
Okay, yeah. Good question, though. All right, so we're going to start with some of these questions. And when you come to your lecture, and even when you do the asynchronous ones, you should have your pencil and your paper and your calculator ready. So if you don't have that, just go and grab one right now. Okay, grab the stuff that you need, because we should be doing this work together. We shouldn't just be like, you shouldn't just be watching me do it, because you're not going to learn much, right, by just watching me. So go ahead if you know how to do this, because this is stuff you probably already know. Start solving these and I'll solve them. And you can check and make sure you're getting it all right. And if you're stuck at all, then you can be stopping and listening to what I'm saying, because we're going to solve it together. Okay, so please try to do these on your own. Try to work with me. Don't just watch, because you're not going to learn as much when you watch. And the course is going to get harder, of course, because we're in grade 10 right now. Okay, so I have to angle my camera. So I'm just going to turn, I'm going to turn this camera off, because I'm writing on my screen right now. Okay. All right, so first we're going to start with Pythagorean Theorem and SOHCAHTOA. So when you have a triangle, how do you know that you can use Pythagorean Theorem and SOHCAHTOA? When is it that you're allowed to use those? What kind of triangle does it have to be? Yeah, good. A right angle triangle. Awesome. Good. Okay, so we're going to use those for 1A. So what are we using for 1a? We're looking for a missing side. We know two sides. Yeah, we're looking for x. Yeah, that's the hypotenuse. So what are we using? Are we using SOHCAHTOA or Pythagorean theorem? Yeah, good. Pythagorean theorem. Awesome. So Pythagorean theorem is a squared plus b squared equals c squared. And now it doesn't matter which one we use, which side we put in as a and b, as long as c is the hypotenuse. So this is my c over here. Okay, the hypotenuse. The hypotenuse is always the longest side of the triangle. If you think of the right angle as though it makes an arrow, the arrow points to the hypotenuse every time. Okay, so this is the hypotenuse side C. So that's my x on the triangle. So my a can be the 3 or the 4. It really doesn't matter. So this I'm just going to write a and b as the 3 and the 4. It doesn't matter which one's which. So I have 3 squared plus 4 squared equals, instead of c, I'm going to say x squared. And then I'll solve. So 9 plus 16 equals x squared. 25 equals x squared. And then I'll square root. And I get 5. So really I get plus or minus 5, but it's the length of the side. So there can't be a negative length. So I'll leave it at 5. I am going to look a little bit at significant figures, but I'm not picky with this on the test. You're going to notice on the test, it will tell you to round to, for example, 2 decimal places. And the reason why I really can't enforce significant figure rules in this course is because Canvas isn't good at significant figures. So I can't say that the answer has this many. It can only control how many decimal places. So we're not going to worry too much about it. I'll talk about it in lecture, but on your tests and your exam, I'm not going to tell you. I'm just going to say like 2 decimal places. Okay, so you really don't have to worry about it. You got to show all your steps on a test. I mean, this question's really not hard. So you could have missed a bunch of steps here. Okay. This question on a test would be it would be like where you just write the answer and you don't take a photo of your solutions. It's too easy to get part marks for this question. Okay. So when you're doing it, just make sure, so I don't care what your solutions look like for a question that's as easy as this, because really you could just type this on your calculator and get the answer, square root of 3 squared plus 4 squared. That's totally fine. Okay, good. Okay, so I have x is equal to 5. Are you doing other questions? Because I don't know what's happening. With the b equals 2.26. Mitchell, are you doing another question? You're probably doing b, yeah? Oh yeah, b. Okay, I'm going to keep going. All right, so I have 5. If I wanted decimal places, I can say 5.00. My question has 3 significant figures given, so my answer, I'm going to give 3, and I'm going to remember my units. Okay, on Canvas, you cannot input units. That's kind of like the biggest problem with Canvas, I find, with these kinds of tests. I can't say, like, enter your answer, and then you put 5 centimeters. You have to just write 5.00 or 5. So it says that in the question, enter only the numerical value in the space below. But then if it's a question that I want you to show your work and take a photo, it'll say, you know, like to take a photo of all your solutions. And for your solutions, you write the units. Anything you're going to show a picture, make sure it has all the units in it. But when you're entering it into Canvas, there wouldn't be any units. Okay? Because you can't enter units, and it won't let you enter the units in Canvas. Okay, so we're going to do this again with B. This time my C, the hypotenuse, is the side that's given. So again, hypotenuse is always opposite of the 90-degree angle. It's pointing to it. And I have A and B. It doesn't matter which one's A and which one's B. And I can just put in the formula, A squared plus B squared equals C squared. My A is 2.8. My B is X. And my C is 3.6. And then I can rearrange to solve for X. 3.6 squared minus 2.8 squared, and then I can square root. And I'm just going to calculate it. .26. I'll put 3 significant figures, so 2 decimal places here. and it's meters is the unit. Yeah, good. Awesome. Are there blank slides posted? Yeah, the blank slides are always posted. So if you have a printer, you can always print them out and then write on the actual pages. But if you don't have a printer, you can just write it on regular line paper. Okay, so I'm going to do C. If you have questions, don't worry about interrupting me. Just turn your microphone on. It's easier for me if you turn on your microphone and ask your question. If you really don't want to do that, you can enter in the chat, but the chat's kind of moving and I don't always see it. Okay, so I'm going to do C. Thanks for posting answers to C. Let's check. So I'm going to do the same thing. So my C is the hypotenuse. My A and B are here. So I'm going to write A squared plus B squared equals C squared. My A is 2.47 squared. My B is X, 6.78 squared. Solve for X. And I get about 6.31, and the units are kilometers. So good job. Good. Perfect. Awesome. Okay, so let's keep going. So I'm going to give you guys some time to do 2. So why don't you start doing 2 and then write the answers that you're getting into the chat. And I'll do 2 as well. 2A, good. Go back to C. Yeah, sure. Okay, so start working on the second question, then we'll go through it quickly. I'll make sure you can see B as well. Now, if you don't see you don't see the second question on my page, like on my screen, but you should be able to just open it in Canvas. Okay, so for the first one, for 2A, what are we using here? Are we using SOHCAHTOA or are we using Pythagorean Theorem? Yeah, good. Awesome. Good. Okay, so Pythagorean Theorem is if you know 2 sides and you're looking for the third side, and it has to be a right angle triangle. SOHCAHTOA is if you know a side and an angle, or maybe you know 2 sides and you're looking for an angle, then you're using SOHCAHTOA. And again, it has to be a right angle triangle. Yeah, good. So I'm going to start to label things, but I'll start by writing SOHCAHTOA. Some people never heard of SOHCAHTOA, so I always like to write it out in case some people just are told to memorize all of them, but I always use SOHCAHTOA. So I'm going to start to label sides. So this is the angle here that I know. And so the opposite side of that would be over here. And then we've got our hypotenuse, which I said is always opposite of the 90-degree angle. So that 90-degree angle always points to the hypotenuse. And then that means that the other side is the adjacent side. Okay, adjacent means next to. So it's next to the 42-degree angle, but it's not the hypotenuse. It's the other one. The one that's next to it, but not the hypotenuse. Oh, that was horrible. Okay. All right. So here, what is it that we're looking for? We want A. The question asks us for A. So we're looking for the opposite. And what is it that we know is the hypotenuse? So we're looking for something that has opposite and hypotenuse in it. So that's why we're going to use so, right? So we're going to say sine of our angle, which is 42 degrees, is equal to the opposite side, which is A. That's what we're looking for, over the hypotenuse, which is 32. And then we can cross multiply if we like. So we can say A times 1, which is A, is equal to the other 2 sides multiplied by each other. So you can just write that as 32 sine 42. Okay, it's in degrees, so your calculator has to be in degrees. And in this course, you're going to find it's going to be in degrees all the time. So make sure your calculator is in degree mode. 32 sine 42. So I get 21. Yeah, awesome, guys. 21.4, and that's centimeters. Good. Okay, so I'll do B. So B, this side over here is the opposite. This other one's adjacent. The hypotenuse we don't know, and we're not looking for it. So we're looking for the SOHCAHTOA, whichever one gives us opposite and adjacent. So that would be tan. So we have tan, because it's TOA. Tan of our angle, which is 21, equals opposite, which is B, over adjacent, which is 14. So again, I can cross multiply. I get B when I do it this way, equals, and then this way I have 14 tan 21. And I can just type that on my calculator. 14 tan 21. 5.37. If you're rounding something, make sure you're rounding properly. So if it was 3.7 and you wanted it to just have one digit, it would be 4, right? 5.4, because the 3 gets rounded up since the number after it is 5 or greater. So 5.4, and that's meters. Good. You're getting the right answer. Awesome. Okay, so we'll do C. So C, this side here is the hypotenuse. We're looking, or we have the adjacent side, and this is our angle. So we'd say we have A, we're looking for hypotenuse, so we're using CA.
Excuse me, Professor. Someone wants you to explain the part B again.
Oh, thank you. Thanks for telling me. She can't see your messages. Oh yeah, slow down. Yeah, I'm so fast. I can see, I know what you mean. Okay, so first of all, Atta, you're saying she can't see your messages. What are you referring to?
I think you were explaining the questions and you couldn't get our chat, get to the chat window. That's why.
Oh, okay. Okay. So should I start from like an earlier one, or should I redo B? Somebody said, can you please explain how you solved B? So should I do that one? I'm going to do that one. Okay, so we're going to do B. So with B, we know this angle over here, and we're looking for the side opposite of it. So the first thing you need to do with your triangle is label the sides. So the side that we're looking for is called opposite because it's opposite of the angle that we know. And then the side that we do know, the 14 meters, is the adjacent side because it's next to the angle we know. It's like the side that's touching where that angle is, but it's not the hypotenuse. So this is the hypotenuse. So because we're looking for the opposite and we're trying, and we know the adjacent, then we need to use SOHCAHTOA, the one that has opposite and adjacent in it, which would be TOA. So we're using tan here. So the way TOA works is you'd say tan of the angle, which is 21, is equal to opposite, which is B, over adjacent, which is 14. Okay, and then you cross multiply. So when you cross multiply, that means you make tan 21 over something. So you want to make both sides a fraction. So you would just make it over 1 because tan 21 is the same as tan 21 over 1. The 1 doesn't do anything, but it allows you to cross multiply. So now you're multiplying 1 times B, which is just B, is equal to, now you're multiplying the other diagonal, which is 14 times tan 21. So you just write them next to each other, 14 tan 21. So now you have B is 14 tan 21, and you type that on your calculator. Okay. Yeah, so I typed that and I got 5.374, and I just rounded it to be 5.4, and that's in meters. Okay, good. Okay, Ali, I hope that helped you. Okay, I won't go quite so fast. It's hard because I don't want to go slow for people and I don't want to go too fast. So you have to tell me because I don't know.
Hey, Miss.
Yep.
Are we to assume the last two are also right angles?
Yes, good point. There really should be something here to make it clearer. So I'll put it in now. Okay. So when we do part C, we'll say, okay, we're looking for the hypotenuse. Right? That's the one that's labeled as C. That means I'm asking you to find that side. So that's the hypotenuse. And the side that we do know is the adjacent. Okay, the other side is the opposite because it's opposite of the angle, but we don't know the opposite and we're not looking for that. Okay, so we're going to use CA because cos of an angle is equal to adjacent, which we know, over the hypotenuse, which we don't know. That's what we're looking for. So I'll write it out. Cos of the angle is 49, is equal to the adjacent side, which is 27.3, over the hypotenuse, which is C. Good, so some people are already getting the answer. So go ahead and type the answer if you're getting it. Now I'm going to cross multiply. So when I cross multiply, it doesn't matter which diagonal I do first. I'm going to do this diagonal first because it's the one that has C in it. So it would be C cos 49. Okay, because when you multiply two things, you can just, if one's a letter, you can just put them next to each other, is equal to 1 times 27.3. So that's 27.3. And now I'm trying to solve for C, so I want to divide both sides. So I would divide both sides by cos 49. Okay, so that cos 49 cancels, and now I can type this on my calculator. And I'm going to say that we get 41.612. So I'm just going to say C is equal to 27.3 divided by cos 49 is 41.6. And the units would be kilometers. And now you're doing D. You guys are amazing. Good. Okay, so let's start doing D. I'm going to leave C so that it's in view. So for D, this is the angle we know, 32 degrees. 121 then would be the opposite side. And D would be the adjacent side. And the hypotenuse would be over here. Hypotenuse is the longest side, and it's opposite of the 90-degree angle. Okay, so now we know the opposite, and we're looking for adjacent. So we should be using TOA. Tan of the angle, 32 degrees, is equal to opposite, which is 121, over adjacent, which is D. Yeah, good, TOA. Good. Okay, so now I'm going to cross multiply. So I'm putting D, timesing it by tan 32, so that just becomes D tan 32 equals 1 times 121, so I get 121. And then I'm going to divide both sides by tan 32, so I get 121 over tan 32. And we are getting different answers, or no? 193.6, I'll just check it. 121 over tan 32. Yeah, 193.6, perfect. That's it. Good. 193.91. Maybe, I don't know, and that's why your answer is slightly off. Check it again, because maybe you did, you know what you probably did? I'm guessing is maybe you did tan 32 first, and then you wrote down the answer, and then you did 121 divided by that, but you didn't include all the decimals, so there's rounding errors, and so your answer's off by a tiny bit. That's my guess. Okay? Because I typed it all at once, and I got 193.640478. Okay, so that's it for that question. Okay, so I'm going to move on. Any questions about any of that so far? Do you want me to revisit anything? As a reminder, all of this is getting recorded right now, and it is going to get posted in Canvas, so you can review. But if you have a question right now is the time to ask. We're good? Okay, so now we're moving on to 3. And the question, for question 3, we're asked not just to find a side, but to find an angle this time. So we're looking for the missing angle. Okay, so if you know how to do it, go ahead and start. And if you want to type your answer for 3A, this should say A here. And this one's B. So if you want to type your answer for A, then go ahead and do that. So we're looking for the angle. Okay, so I'm going to start the same way. So we're just going to label the sides. So this is my angle here that I'm looking for. So opposite of that is called the opposite side. And then the hypotenuse is always the side opposite of the 90-degree angle, which is the longest side of the triangle. And then this other side, the last side, is the adjacent side. It's the side that's next to the angle, but not the hypotenuse, the other side. Okay, and so we're looking for x this time. So x is the angle, which means that we need to know two sides. So the two sides that we know are opposite and hypotenuse. And if you think of SOHCAHTOA, then that would be SO. SO is the one that has opposite and hypotenuse in it. So this time we need to have one that has both sides in it because it's the angle that's missing. So I would write it out as sine of my angle, which is x, is equal to opposite, which is 21, over hypotenuse, which is 33. I think, yeah. Okay, and then we're solving for the x now. So we want to solve for this number, whatever this angle is, the x. So really what we want to do is get rid of sine, right? We want to move sine to the other side so that x is by itself. And some people try to divide both sides by sine, but that doesn't work because sine's not a number, it's a function. So in order to bring it to the other side, you're taking the inverse. So anytime you're solving for an angle, you're always going to use your inverse buttons on your calculator, right? So it's like the second function or the shift with your trig functions, it's always going to be using one of those inverse buttons. So I'm going to just bring the the sine to the other side. So I have sine inverse of 21 over 33. Okay, so I'd suggest not doing 21 divided by 33 to get a decimal and then doing sine inverse of that decimal, because then you'd have rounding errors. So you're just better off doing sine inverse of the whole fraction instead. Okay, so I'm going to do it on my calculator, sine inverse 21 over 33, and I'm getting 39.5. Again, make sure your calculator is in degrees. So I have 39.5, and my units are degrees. Okay. Okay, so now you're doing the other one, so B. Awesome, so I'll keep going. With B, I'll start labeling everything. When x is my angle, then the opposite side is the 11 meters, and the adjacent side is the 17. So that means I'm going to use tan because of TOA. Tan of my angle, which is x, is equal to the opposite side, which is 11, over the adjacent, which is 17. And then to solve for x, I just have to take my tan to the other side by doing tan inverse of 11 over 17. And I get 32.9. Good. Awesome. Good. Okay, so I'm going to do C. So with C, we know the adjacent side and we know the hypotenuse. So what are we using here? SOHCAHTOA. Which one? Adjacent, hypotenuse. Yeah, good. So Ka. So we have cos of the angle, which is x, is equal to the adjacent side, which is 27.3, over the hypotenuse, which is 41.7. So I'll solve for x by bringing the cos to the other side, but we have to do inverse to bring it over. 27.3 divided by 41.7. And we get 49.1 degrees. Perfect. Good. And then one more, D. So for D, the opposite side is 119. The adjacent side is 149. So we're doing tan. So TOA tan of the angle x is equal to opposite, which is 119, over adjacent, which is 149. We'll bring the tan to the other side. And we get 38.6. Yes, good. Degrees. Perfect. Okay, any questions about any of this? So we've done Pythagorean theorem, SOHCAHTOA to find a missing side, and SOHCAHTOA to find a missing angle. We're all good? Good. Perfect. Okay, vectors. Ooh, maybe I'll play this. How's it going to work if I play it? Okay, you guys can play it on your own, I think. I don't know if it's going to work with in Google, but you can play it. I'll let you guys play it. Go back to Z. Yes. There's a video and it might bring back childhood memories. It's okay. So who could think of a movie that has vector in it? Somebody whose name is Vector in a movie. Yeah, Despicable. That's it. So it's a scene where like Vector, the character in Despicable Me, says, I'm a vector, and a vector has a magnitude and a direction. That's what that video is. But you got the better version because you got me imitating it, which is better. But you can watch it now. Okay, so state the direction of the following vector. Okay, so now we need to start stating directions. And you'll notice A and B have east, west, like northeast, southwest coordinates. And C and D have X and Y axes. So the way we state these directions are going to be different. Okay, whether they have northeast, southwest coordinate system or X and Y coordinates. Okay, so yes, let's start. I want to start asking people what would be the answer for A. How would you say that direction? There's a vector that has a 30-degree angle between the east and the north axes. So you wrote east, 30 degrees north. Somebody else wrote 30 degrees to northeast. East, 30 north. 330 degrees from north. 330. East, 30 north, east, 30 north, 30 north of east. Good. Okay. So the correct two answers that we will take is east 30 north or 30 degrees north of east, because those both mean the same thing. We're not doing it like, we're not finding this angle like this. Okay. That's not the way we're going to state the angle in this course. We're not stating the angle like, you know, this way, like you would in math, where you say it from the positive x-axis. We're always going to say east something north or north something east, or we can say 30 degrees north of east. So let me just go over those two options quickly. So the one is you're starting with east, and from east, you're going 30 degrees towards the north direction. So that's one option. East, 30 degrees north. So on a test, you'll see a picture like this, and it will say what is the direction, and it will be multiple choice, and you'll choose the correct one. So there's two options for the answer that it would be correct. Okay, so one of them is east, 30 north, and the other one is 30 degrees north of east. So that means from the east line, you're going 30 degrees north of that, towards the north line. Okay, yeah, I'll explain it again because it's confusing. So the first one is east 30 north. So that means from the east line, you're going 30 degrees towards north, because this is north up here. So you're traveling 30 degrees towards north. So that would represent this vector's direction. Yeah, Muhammad, you can ask your question.
Hi.
Hi.
I'm wondering, so whenever labeling, is it a rule where you always say the x-axis first and then the y? Or is
No.
it just in this situation because they wrote it 30 degrees this
Yeah,
way? Okay.
that's right. So I could have given it the north
Forward
first and then the
and
east
yeah.
also.
Then
Yeah,
what I said north.
either of
So
them
you-
is fine.
Yeah. So you just say like east. So you say wherever you start.
Yeah.
So you start at the east,
Yeah.
and then you end up moving towards the north.
Yeah,
So then
by
it's east
30
30
degrees.
north.
Yeah, so
Got
it's
it,
you
okay.
start at east, and then from there you're going 30 towards north.
North. Got it. Thank you so much.
Yep, no problem. Okay.
Can you say north 60 degrees east?
Can I say north? Yeah, you can definitely say that. So I could say also this is 60 degrees because together these are a right angle. So I could have said I'm going north, and from north, I'm going 60 degrees towards the east line. So it would be north, 60 degrees east. So that would also be a correct option. Okay. 30 degrees northwest is not the way it's going to be phrased. So don't phrase it that way because it's not clear as to whether you mean from north to west, like 30 degrees north of west, or 30 degrees west of north. It's just confusing. So write it down, 30 degrees north of east, There's, I don't know if you're doing, yeah, you're probably doing B, but A doesn't have any west in it, right? Easier to give the value 30 degrees northwest. Yeah, so don't say 30 degrees northwest. Say it east 30 degrees north, or say 30 degrees north of east. But I don't, maybe you're having a different conversation in the chat. Is 60 degrees north, is at north 60 degrees west the same as west 40 degrees north? So 60 plus 40 is 100. So it should be adding to 90, not 100. So north 60 west is the same as west 30 north. Got it? Are we good? So what's the last option here that I could write this first, like part A, the angle as? What's the last option? Because I wrote east 30 north, 30 degrees north of east, north 60 degrees east. And what's one more way I could say this? So like using this form here. 60 degrees east of north. Yeah, perfect. So 60 degrees east of north, that's the other option. Good. East 60 degrees north is not right because it's east 30 north or north 60 east, but not east 60 north. Okay, somebody raised their hand. I can't see who anymore for some reason. Is there still a hand up or no? I don't see it. If you have your hand up, you can start speaking. We good? Let's practice some more. Somebody have a question? Okay, let's practice the next one. So basically, the question on the test will show you a picture and it will say, what is the angle represented by this vector, or what is the direction of this vector? And it will give you a bunch of options, and one of them will be one of these four. And then that's the one you select. So there could be like opposite ones. Like I might have north 30 degrees east, which is not right. So you wouldn't select that one. So you have to make sure you get what's what here. Okay, so let's do it again with B. And hopefully by the end of these, you'll be experts. Good. Okay, so for B, we're starting with west. Oops. We're starting with the west line. So we're going west over here. And from west, we're going 40 degrees towards north. So that's what it would be. West, 40 degrees north. But the other way of saying that is 40 degrees north of west. Okay, some people hate this way, but you kind of have to know it, because if that's the correct answer in the multiple choice, you need to be able to select it. So one way you can think of it is you can take this number here and move it over here, and it becomes 40 degrees north of west. So that west letter, you can just move it afterwards. So if you can't think of it in this terms here, in the bottom terms in that respect, just take the one that you do understand, west 40 north, because to me that's the easier one, and move the west after the north, and it becomes 40 degrees north of west. So visually that might be able to help you see the second option. But what it means is you're going 40 degrees north of the west line. Here's my west line, and you're going 40 degrees towards the north of that. So it really means the same thing as west 40 degrees north. Questions about that? Smart. I don't know if you were referring to what I just said, but yeah, thank you. Okay, so now I'm going to write it the other way. So if instead I wanted to change it to be north and west instead, then what would my angle be? North, how many degrees towards the west? Good, 50. Right? Because if that's 40 over here, then this has to be 50, because together they make 90. So north 50 west, or I can take my north and move it over here, and it becomes 50 degrees west of north. Yeah, good. All right, I think some people might like that trick. All right, so that's B. Okay, so go ahead with C. I'm not sure, Akshayan, what you're saying, what you're talking. What are you talking about? x15 minus y minus x45 minus y. I don't know what that question is. You can turn on your mic. Oh yeah. I don't know. You're super smart because your language is the math language. Would you be asked to do both? The question, if it was a question that was, let's say the question asked you for the velocity, and I want a velocity is a vector, so you're going to have to include a direction. Well, in that case, then you're going to put in a direction, and it's just one direction. It doesn't matter which one you choose, which way you want to say it. So no. But if the question was asking which of the following directions is this vector moving in, then you would have to choose the correct one. But it might be in the one form or in the other form. It could be in any way. So you have to figure out which one it is. So I'm not going to ask you to write it in like different forms, but you have to recognize which one's the right answer. Okay, go back. So let me just make sure you guys can see C. Vectors pointing left and downward have negative x and y components. Yep. Okay, be careful when you do C because C is different now. C doesn't have northeast, southwest, so you're not going to say east 15 degrees south for this one, right?
Yeah, sorry. Yeah. So what my question really was is like for A or B. So you, we first did E, like east 30 degrees north, right?
Yeah.
And then below that, like we did north 60 degrees east. Are we supposed to do both of them or only one?
No, I'm just giving you options. I'm telling you like which ones are correct. But on a test, I'm going to give you a bunch of wrong options and one correct one. And the one correct could be any of these four.
Okay, okay.
Okay, yeah.
All right, thank you.
Marion, do you want to ask your question? Or are you okay?
I'm all right, thanks.
Okay, no problem. Okay, so let's go ahead with C. Does anybody have an opinion or a thought about how you would state the direction of vector in C? X minus 15y. X negative y, or 15 minus y of x. Yeah, you're getting close. So the way I would say it is a certain number of degrees above or below the positive or the negative x-axis. Okay, so let's start with the number of degrees. How many degrees is this one? 15 degrees. So I'm going to say 15 degrees. Is it above an axis or below the axis? Below. And is it below the positive x-axis or the negative x-axis? Yeah, good. 15 degrees below the positive x-axis. That's it. Good. This one's easier. Okay, what about D? So we'll start with the angle. Actually, I'll give you a second. Write it down. Yeah, that's the only option that I want to see. Because technically you could say, you know, you could say 75 degrees to the right of the negative y-axis. This is just so confusing. Let's stick with x-axis. 15 south of east. Oh yeah, that's a really good question because on the axis here, it doesn't say northeast, southwest. It says x and y. So it's like, if I want you to take 5 steps forward, that doesn't mean you're traveling north, right? You can't just always assume north means up or forward. You know what I mean? So don't say north to me if the question doesn't say north to you. That's all. So use x and y if the question gives you x and y. 45 degrees below the negative x-axis. Yeah, that's awesome. Yeah, and I see what you mean, Mohammed. Like, it's not always very obvious, but you have to look out for whether the question gives you northeast, southwest, or if it's just x and y. Awesome. 45 degrees below the negative x. Yeah, perfect. So the angle's 45 degrees. It's below, and it's the negative x-axis. That's all. Are we good with that? Yeah, good. Great. Next. So the next thing that we're doing here is we're going to find the magnitude and the direction of a vector. Okay, so in the question, they tell us the x component and the y component, and we're using those to get the magnitude and the direction. Oh, go back. Sorry. Okay, so if you have the note on you, you can try the first question. What I want you to start doing is drawing a picture of what's happening. So you have the x component, so you should be drawing a vector that travels in the x direction and another one in the y direction. Okay, wait. What if it was in the positive y direction? So if it was like this, right? How would we say that one? Let's say it was still 45 degrees. What would the difference be? What's the one word that has to change? Yeah, good, above. It would be 45 degrees above the negative x-axis instead of saying below. That's all. I will write it in somewhere. I'll do it here. So this one is 30 degrees above the negative x-axis, just so you can look at it in the notes. Good. Okay, I'm going to move. Oops. I moved the wrong computer screen. Okay. Next, if you know the x and y components of a vector, we can find the magnitude and the direction. Okay, so let's do this. We want the magnitude and direction of a vector that has an x component of 32. So that means, is it going left or right? If the x component is positive 32, it's going to the, yeah, good. So it looks like this, 32. And it has a y component of negative 14. So which way is that going? It's y, and it's negative. Can you guys hear me? Okay. So what's happening? Mohammed, you can't hear me anymore. I hope you can sort it out. Okay, good. All right, so we're going 32 newtons is the x component. It's positive, so it's going to the right because x is left and right, but it's positive, so it's right. And then the y component's negative 14, so it should go down, right? So y axis is up and down, but since it's negative, it goes down. And it's 14 newtons. Okay, I could put a negative, it doesn't really matter. And I'm looking for the magnitude of this vector. So that would be this vector here. So I know the x and y component of it. That means if I break it down into a triangle, the x value or the horizontal length of that triangle is 32 and the y value is 14. It's negative because it's pointing downwards. Okay, so now I'm looking for the magnitude of this diagonal. Well, that diagonal there, this makes a 90-degree angle because we've got right and down. So those are 90 degrees to each other. So this is like my hypotenuse. So really I'm asked to find the hypotenuse here. So when it comes to find the magnitude, that means find the hypotenuse. Okay, so back to where we started today, our first question, I think, finding one of the sides of a right angle triangle. So you're using Pythagorean theorem. So hypotenuses are c, the other two sides are a and b. So I have a squared plus b squared equals c squared. My a is 32. My b is 14 or negative 14. It doesn't matter because you're going to square the number anyway, so it'll be positive. If you're putting in the negative, though, make sure you're putting in a bracket so that when you square it, it becomes positive. So c is equal to the square root of all of that. 32 plus negative 14 squared. Okay, if you don't put a bracket and you're putting a negative, you're not going to get the right answer. So make sure you're putting it in the bracket or just don't even bother with the negative. So square root of 32 squared, right? I forgot the squared. 32 squared plus 14 squared, and I get 34.9. And that would be newtons. And that's my magnitude. 34.928 newtons. Good. Perfect. So it's 9284 So it stays as 928. If you're going to round it that much, I'm just going to write 34.9. My question has 3 significant digits, so my answer should have 3. Again, you're not getting tested on that, but it is good to be aware because some of you are in engineering. It's pretty important. But basically, as whatever number of significant figures is in the question, that's what your answer should have. But on a test, it's going to tell you. And I think at this point, all the tests I've made, I've been saying like 2 decimal places. Okay, what about 32? No to the power of 2. Yeah, I fixed that. Right? I think I fixed it. Can magnitude be negative? I thought only direction can be. Do we need to round it in 3-digit or in 2-digit in decimal? Okay, so technically, when you're giving an answer, the number of significant figures of your answer should equal the number of significant figures of the numbers that are given to you in the question, so the least number that are given to you. So the correct answer should have 3 digits because my question, the 2 numbers that were given to me have 3 digits. But as far as tests goes, which is where you're getting your marks in this course, the tests and the exams, I'm going to tell you, so I'll say round to the nearest something. So I'll probably say round to 2 decimal places, and then you'll write 34.9 something, 9.3, for example. Okay, magnitude cannot be negative, but when you square root something, you're never going to have a negative, so that's fine. You're not going to have a negative answer here. The negative that's in this 14 doesn't matter whether you put it in or not, because when you square it, it becomes positive anyway. So it doesn't matter whether you type that into your calculator or not. Okay, I think I answered all the questions. Let me know if you have any questions right now. Yes, go ahead, Surandar.
I didn't mean to raise my hand.
Oh, no problem. Yeah, and you guys don't need to raise your hand. You can just turn on your mic and speak. Mohammed? Just as
Yeah, sorry. So you said it doesn't matter if you have the negative or not, but you get 2 different answers when you do.
Did you put it in a bracket?
Yeah, I did.
No, you didn't.
I'll do it
32 squared plus bracket negative 14 bracket squared.
Negative 14 squared. Square root. Yeah, I did it again.
No. What she means is if you just don't put the negative, it's all okay.
So
But I get the
this
same. But I get
bracket
a different
here,
answer.
no,
You don't have to have the negative because it's a magnitude anyways.
I get that.
because it's because of the squared. So negative 14 squared is the same as 14 squared. As long as you put the bracket, negative 14 squared is not the same as 14 squared. So that's why the bracket is needed. And the bracket has to be where it is, where I drew it. It can't be after the squared, for example.
Yep. Thing is, I'm doing it like I did it 6, 7, 8, 9 times. So I guess.
Okay, stay after the class and then you'll show your actual calculator to me and then I'll see what's going on.
All right.
Yeah. Okay. All right. So this question is not finished because it wanted the magnitude and the direction. And all that I gave right now was the magnitude. Right? So we also need the direction. So which direction is it that we're looking for? So we need to find an angle in this right angle triangle. So which angle? Is it the top angle or is it the bottom angle? How do you know? Bottom, bottom, top,
I think
top.
it's top because the arrow points downwards, right?
Yeah, it's from the beginning. Say like if you were a little person right here and somebody's telling you which way to go, right? It's from the top because that's the direction you're going. So it's from the top. So this is the angle you're looking for. So I'll put a little symbol here. I'll say theta is my angle. So I'm looking for that theta. And so when I solve for theta, I could use any of the 3 sides, but really it's better not to use the hypotenuse because I just solved for the hypotenuse and there's rounding errors there. So I'm better off using just the 32 and the 14. So I'm going to say, because 14 is my opposite side and 32 is my adjacent side, then I'm going to use TOA. So I would say tan of my angle. Mohammed, do you have a question? Or
Yeah, so I figured it out. I put the squared inside the bracket.
In the bracket, yeah.
My mistake. Okay.
Yeah.
But you said bracket. I thought you meant like including the squared inside the bracket.
Yeah, I know.
Thank you.
Yeah. So you can just not put the negative and then you don't have to worry about it.
Yeah.
Yeah.
Thank you.
So tan theta equals opposite, which is 14 over adjacent, which is 32. Okay, notice I'm not putting a negative in front of the 14 because if I did, I would be finding not the acute angle, but I'd be finding an obtuse angle. So we don't have to go back into like cast rule and trigonometry, but when you're doing this, you're really just looking for this angle, and the length of this vector over here is 14. It points downwards, but the length is still 14. Okay, because you don't want to be finding like this angle, for example, right? The whole angle all the way around. So don't worry, just always use the positive values for the lengths because we're talking about lengths of the triangle sides. So tan theta equals 14 over 32. We're solving for theta, which means we're bringing the tan to the other side by taking the inverse. And so then we get tan inverse of 14 over 32, 23.6 degrees. All right, so now we have the magnitude and we have the angle. Mihai, do you want to ask a question?
Hold on. Yeah, I was muted.
No
So
problem.
I wanted to ask, after this course is over, I can take Physics 2 for computer science students, right?
Physics 2, yeah. Physics 2 for like anybody who needs Physics 2, not just for computer science. Yep.
Because I did pass the first time, so like my schedule is a little off. So I'm just,
Yeah.
asking
I
basic
think they're
questions.
offering Physics 2 in the spring.
Thank you.
Okay, no problem. Okay, so now that we have the magnitude and we have the angle, we need to put it together to find magnitude and direction. That angle is not the direction, right? If we think back of the last slide, the way we were giving those directions, that's what I want for direction, not just an angle. Okay, so if you have to give magnitude and direction, the direction is not just the angle by itself. How would I say this direction here? So I'm going to put it in square brackets. So it said x component and y component, right? So we're not talking about northeast, southwest. So we're not going to say east 23.6 degrees south. We're going to say it in terms of x and y. So I'll just draw like my little x-axis and my y-axis. And we're talking about the direction of this black vector here. So how would we say that?
23.6 below the x-axis?
Yeah,
Positive
good.
x-axis?
Yeah, good. Perfect. So it's 23.6 degrees below the positive x-axis. That's it. Okay, next one. The next question is the same. What is your total displacement? Displacement is a vector, so that means you have to include the magnitude, which is the length of the hypotenuse, and the direction. So you have to find the angle and do the same thing. Okay, this time though, the question is north and west. So you're not going to be stating it as below or above the positive or negative x-axis. So go ahead and draw these two vectors. You're going 35 meters north. And then from there, so from where you ended up, you're now going 18 meters west. And we want the total displacement. Okay, so our displacement vector, it always goes from the beginning of the first vector down here to the end of the last vector. So it's going from the beginning to the end. So our vector looks like this. Okay, notice I had to attach those first two vectors, the blue one tip to tail. I couldn't do like 35 and then 18 like this. You can't add them like this when they're tail to tail, like the two tail ends are touching each other. You have to make them tip to tail. So the 35, from that point where you finished, you then go 18 meters west, tip to tail. So the tip of the first one touches the tail of the second one. And then the displacement is from the beginning of the first to the end of the last. So now we're doing the same thing. We're going to try to find the magnitude and the direction because displacement means you have to include both. So I'm labeling my two sides. I can use Pythagorean Theorem. You can go ahead and just answer the question on your own and then look up if you need help. So on a side note, it's 3:27 and we're not done. And so because this lecture is recorded, I'm going to keep going whether people are here or not. And then you can always just watch the end. There are some questions, I think it's 8 and 10, that are posted in the video solutions already. So there's solutions of them as like already in the homework section. So we were going to skip those ones anyway. So there's question 7 and 9, I think, that we were going to do together. So if you have to take off because it's 3:28 and the lecture ends at 3:30, then feel free to just log out whenever you want to or when you have to. And if you want to stay, if you want to ask questions, then you can hang in here, okay? But I'm going to keep going. We had too much fun at the beginning chatting. Okay, 39.4.
Sorry to disturb you. Are you
Okay.
just going to finish the worksheet? Is that how long you're going for?
Yeah, I'm just going to finish and then I'll stick around if people have questions too.
Okay, thank you.
Okay, but if you have to head out, you can just go to when I post the video. I'll post the video later today when it's it has to like appear in my Google Drive, then I'll post it. And then you can just watch like the ending. So you can just scroll through the video till you get to this point where you left. Okay, and now I'm going to find the angle. So we said we're finding the angle from the beginning of the vector. So that's the bottom in this case. And we're going to say tan. We're always using tan because the 18 and 35 are numbers that were given to us. So they're exact values, whereas the 39.4 was something that we calculated and it has rounding errors in it. So it's better to use the exact values. So tan theta equals opposite, which is 18, over adjacent, which is 35. And then we'll bring the tan to the other side. And we get 27.2. And this time, so it's asking for the displacement. So it's 39.4 meters. And now when we give a direction, we are talking about north and west. So what would this direction be in this case? Yeah, so displacement, and in our next lecture, we're going to talk about vectors versus scalars. But vectors is, displacement is a vector, which means you have to include the direction. So you need to include it for displacement. So it'll be north, 27.2 degrees west. Yeah, perfect. Running. Okay, hands up. E-F-E. Efi, I think?
Effie.
Effie.
It's
Okay.
Effie.
That sounds
I just want to know the angle. We always use the angle between like that intersection there.
Yeah, so you're finding the angle in the triangle, and you're always going from where the vector begins. So that displacement vector started at the bottom, so that's why you're finding the angle at the bottom. Whereas in the question before, the vector started from the top, and so you found the angle from the top.
Okay.
Okay, so this is north, 27.2 degrees west. Or 27.2 degrees west of north. Good, Marion. Question 9, I'm going to get to. Okay. All right, so I'm going to move. Okay, can you draw the extended axis for direction like that of 5? Yes, I think I know. Yeah, I'll draw it in a different color. This is north. The axes have to be from this point here, so it'd be like this. Okay. Why is it north 27? So you can't put the of in there. So Roma, you can't put the of. So it would be north 27.2 degrees west. So what that means is you're starting at north, and from there you're going 27.2 degrees towards west. Is splitting of vectors on the agenda. I don't really know what you mean by the agenda. Like the plan for the day? I'll give you some time to absorb everything on this page. But decomposing vectors is something that you're doing in this course. And it's something that could be asked on a test, for example, if that's what you mean by the agenda. Yeah, the plan for the day. Okay, the next thing I believe, yeah, on the next slide is vector addition. So in order to add vectors to each other, we decompose them. Oh yeah, the splitting of vectors. So what's coming up next? Yeah. So that's on the agenda. As I mentioned, we don't have time during the regular lecture time. If you have to go, just go. It's totally fine. It's being recorded, so I'm going to keep going, and you can always go to this part of the lecture and complete the rest of it. How much longer? I really want to stay, though. Okay, I'll try not to talk. We'll continue. There's 2 more questions, and one of them's pretty long. So I'm going to guess 15 minutes. But it's recorded, so don't feel like you have to stay. Mohammed, do you have a question?
Yes. So for question 5, so right now we're on 6. So the one before that.
Yeah.
So the way we drew it was we did the x component first, and then we drew the y.
Yeah.
And then we got that answer. So I'm wondering, would we get a different answer if we did it in reverse?
Yeah. So if you did it like this.
Yeah.
The y first and then the x, your hypotenuse would still be the same, right? So you'd still get 34.9. But when you found your angle, you'd be finding this angle, and it wouldn't be 23.6. It would be 66.4.
So yes, that's my question. So then would you accept both answers?
Well, the way you would say this, though, would be a little bit confusing, because you would still want to say certain number of degrees below the positive x-axis. So you would just have to do 90 minus 66.4 to get to your 23.6. And then you would get the same answer at the end. So you'd still say 23.6 degrees below the positive x-axis.
Okay, thank you.
Okay, no problem. All right, bye, Samir. Okay, I'm gonna keep going to the next slide.
Bye, miss. Thank you.
Bye, no problem. All right, so question 8. I wonder if, did I miss one? Oh yeah, there's one here, sorry. So question 7. So now we're gonna decompose vectors. So I have a 7 Newton force acting on an object at an angle of 40 degrees above the positive x-axis. So let's draw that. That was bad. Okay, so positive x-axis, that's this one. 40 degrees above the positive x-axis. So here's my 40 degrees, and it's a 7 Newton force. Okay, find the horizontal and vertical components. So let's break this down. The horizontal component would be this vector, and the vertical component would be this vector. And I'll just label them as x and y. X for horizontal, y for vertical. So we're just solving for those 2 values. Okay, so it's kind of like one of the first questions we did when we talked about, using SOHCAHTOA. So that's all we're doing here. We're trying to find one side and then the other side. So the 7 newtons, if we're talking about opposite, adjacent, hypotenuse, what is that 7 newtons? Which one is it? How would we label the side? Good, hypotenuse. And then what about x? Good. And what about y? Good. Okay, so let's start with x. We're going to ignore y. We don't want y yet. Is it cos for horizontal or vertical? Okay, let's look. We'll see. It depends. That's right, it does. Okay, so for the x, okay, so we're looking for the adjacent, and we know the hypotenuse. So what are we going to use? SOHCAHTOA, adjacent, hypotenuse. It would be ka, right? Because that's adjacent and hypotenuse. So we would say cos of the angle, 40 degrees, is equal to adjacent, which is x, over hypotenuse, which is 7. And then we can cross multiply, and we get x equals 7 cos 40. Okay, and then we can do the same type of thing now to get y. So for y is the opposite side, and we know the hypotenuse. Okay, I'm not using adjacent, I'm using the hypotenuse side because that's the side that was given. So now if we have opposite that we're looking for, we know hypotenuse, so we would use sine of the angle is equal to opposite over hypotenuse, 7. Cross multiply, we get y equals 7 sine 40. Okay, now people memorize this, right? And say, okay, like what Marian said, I don't know, you mentioned earlier that it depends. So that's right. It's not always that cos is for x and sine is for y. Oftentimes it is, but not always. So let's think about it. So when we're looking for the adjacent side, that means you're using cos. And when you're looking for the opposite side, you're going to use sine. But the adjacent side is not always x. Because what if I gave you a triangle that looked like this? This is x, this is y. And this is my angle. Do you see how in this triangle, the adjacent side is y? Right? It depends on how your triangle's given to you. So just be careful. What I do is I don't go through SOHCAHTOA every time to decompose a vector because it takes too long. And you're going to be doing this a lot in the next couple questions that we do. So what you should do is say, okay, I'm looking for the adjacent side and I know the hypotenuse. So it's going to be cos. So it's going to just be the hypotenuse cos of the angle, 7 cos 40. That's it. And it's going to the right, so it's positive. Done. Next, I'm looking for the y value. That's the opposite side, so it's going to be sine. So it's going to be the hypotenuse sine of the angle. So 7 sine 40. And it's going upwards, so it's positive. Okay? So we'll do that. We're going to do it the fast way. We're not going to have to start from the beginning with cos of the angle equals adjacent over hypotenuse and cross multiply. Takes too long. You won't have time. Okay, so now I'm going to just type it. 7 cos 40. I'm going to just write down what you guys wrote. 5.36. And that's newtons. And for the y, it is 4.5. Is that right? I should check. 7 sine 40. Yeah, 4.5. 50. If I want 2 decimal places, I would round that to 50 newtons. Okay, so we're going to practice doing this. We're not going to do it straight from SOHCAHTOA every time. We're going to go right down to the answer now. We're going to just go x. If we're looking for the adjacent side, it's going to be hypotenuse cos of the angle. If we're looking for the opposite side, it's going to be hypotenuse sine of the angle. Okay, go straight to that. Okay, so I'm going to skip 8 just because 8's already, there's a video solution for it. And we're going to do 9. And there'll be a question just like 9 on your test. Okay, and it's probably one of the biggest questions on the test because it involves you doing the most steps here. It is right. Good. Can you repeat what you were skipping? I'm skipping 8 because there's a video solution already in the homework. So in Canvas, you'll see one of the questions, like one of the items in the homework says this is a video solution for question 8. And that's what I'm skipping right now in lecture because you can just watch it yourself afterwards. Okay, so we're going to do 9 together. And then the last question after this is 10, also has a video solution, so we're not going to do that together. Okay, so 9. So what we're going to do for question 9 is we want to find the magnitude and direction of the net force. So there's 2 ways of doing this, but by far the best way of doing it is to find the x and y components of each of the vectors and add them all up and then find the resulted out of that. So I'll show you what I mean. So we're going to decompose each of the vectors or split them up into their x and y components. And we'll do this for T1, T2, and T3. And then when we're done, we're going to add them all up to get the total. So we'll start with T1. Okay, so for T1, I'm going to draw the triangle to decompose the vector. Now, the original vector, you can see T1, it points to the left and up. So when we decompose, it goes to the left and up. So that's really important to note the direction of those 2 vectors that we just drew. They go in the direction that the original one went in. The original one was going left and up, so that's why these two are pointing left and up. So we're going to start with x, and then we'll find y. So in terms of x, is that the adjacent side or is that the opposite side of the 37 degrees? Adjacent, good. So because it's the adjacent side, do we use sine or cos? Think of SOHCAHTOA, yeah, cos. Good. So we're going to say it's the hypotenuse, which they told us in the question is 7, and then cos of the angle, which is 37 degrees. Okay, then we need to decide if it's positive or negative. So should that vector be positive or negative? Which way is it going? So it's it's negative because it's going to the left. So this x component is negative because the vector points to the left. So it's negative here. And then we'll do the same thing for y. Is y opposite or adjacent? Opposite, good. So it's opposite of the 37 degrees, which means do we use sine or cos? Good. So we're going to do the hypotenuse, which is 7, sine, because it's opposite of the angle, 37 degrees. Now, should it be positive or negative? The y value, good, because it's pointing upwards, so the y value is positive. That's it. So now we have to do that with the other two vectors. So T2, decompose it. We're drawing a triangle. I like drawing a triangle that has the angle in it. So I don't draw my triangle here. You know, I could do that, but then that just means that I have to find the angle in that triangle, which is fine. It's not a big deal, but I just prefer to use the angle inside my triangle that's given. I put the arrows on my vectors. So the original blue vector points right and up. So these vectors should point up and to the right as well. And so now when I find the x component of that vector, is that sine or cos? You look at it and you say, okay, well, it's the adjacent side, so it's cos, yeah. So it would be T2, which is 10, tells me in the question. So it's 10 cos 53 degrees. It's pointing to the right, so it's positive. And then I do the same thing for the y. It's opposite, so I'm using sine. So it would be hypotenuse 10, sine of the angle, 53 degrees. And it's pointing up, so it's positive. And then when you're ready, do the same thing for the last vector. And tell me what you get for x and for y. Yeah, good. All right, so if I had a vector that was pointing to the right and say it was 5 meters long, then what would the x component of that be? You can turn on your mic if you want or type it. What's the x component? It's pointing to the right and it's 5. Yeah, good, 5. Okay, what about here? What's the x component?
0.
Yeah, good. It's 0 because it doesn't have an x component because it doesn't point to the left or to the right at all. What if it was like this? What's the x component? Yeah, good. -5. And what's the y component of that one? The same one that we just did. Yeah, it's 0 because it doesn't point up and down at all. So that's what we're doing with this vector. It points straight down. So its x component is just 0 because it doesn't point to the left and the right at all. So it's just 0. And the y component of this one, they tell you in the question T3 is 13, but it's pointing down, so it would be -13. So now all I'm doing is on my calculator, we're going to just type up all the numbers for x, add them together, and give the answer down below. And then separately, we're going to add all of them for y, add them up, and type the answer below. Okay, so we're just adding them all up separately, the x's and then the y's. So I'm typing -7 cos 37 plus 10 cos 53. And then the 0 doesn't do anything. And I get 0.4277. This isn't the final answer here, so I just keep extra digits. So if I only wanted 2 decimal places, for example, I'm keeping extras. So I can even put a little bit more, 0.2, for example. And then 7 sine 37 plus 10 sine 53 minus 13. And I get negative 0.80094. So now I know what my x and y components are of my net force. So this is my net force. Net means when you add them all up, what do you get? So those are the x and y components of the net force. So it's kind of like a question that we did previously, I think. It's like 5 and 6, where they're giving you the components, the x and y components, and they want the magnitude and direction. So we're basically completing question 5 again now at this point. So we are here. So we know the x and y components, and the question wants, what is the magnitude and direction of the net force? So we're doing the same thing over that we did in question 5. So the x component, 0.4. It's positive, so it's going to the right. So it's 0.4277702. The y component's negative, so it's going down. 0.80094. The resultant then would be the hypotenuse. I'll call that C. The other two sides are A and B. We can use Pythagorean Theorem. So we have a squared plus b squared equals c squared. We'll solve for c. A squared plus b squared in a square root, and we'll just plug everything in. So a is 0.427702 squared plus, I can leave the negative out if I don't want to put it in. Or if I do put it in, I put it in a bracket like this. The bracket ends before the squared. And then we can type that up. So I get 0.908 meters. Yeah, others are getting the same thing. Good. And then I'll find my direction. So my direction is always from the beginning of the vector. So that would be up here. And I always use tan. Tan theta equals opposite, 0.80094 over adjacent, 0.427702. Notice I'm not putting in a negative sign. And now I'm going to solve for theta by doing the tan inverse of that. Tan inverse of 0.80094 divided by 0.427702. Close the bracket. 61.9 degrees. My question was about x and y was given to me as coordinates. It wasn't told as northeast, southwest. So now I need to give this as an actual direction. So my direction would be what? And isn't it newtons? Yeah, let's check that. Yeah, it's in newtons. Thank you. So that should be newtons. You are all on the ball. Good. So now we're trying to state this as a proper direction. So direction does not just mean the angle. Yeah, so it would be 61.9 degrees. If I were to extend it, my axis has to be from the starting point. So it'd be like this. So this is my x and this is my y. So it's below the positive x-axis. And that's it. Okay, so expect to see a question much like this one with 3 or 4 vectors, and you have to decompose all of them, add them up, and then recompose them, which means once you get your net, right? So whether it's a force or something else, but once you get that last x and y component of your resultant, then you redraw the triangle, you find your hypotenuse, you find the angle with tan, and then you write it as a proper direction. And that's it. Okay, so the only last question that's here is just more practice for you to do the same thing. There is a video solution, so you can just try it on your own. So try question 8 and question 10 on your own. Make sure you can do this and that you get the right answer, and then check the video solution after. So if you're feeling rusty right now, try to redo the ones that we actually did together. And then when you feel good about it, then move on to 8 and 10. And try to do those on your own. Then check the video solution, make sure your answer is right. Like you can even just scroll right to the end, make sure your answers are right, or watch it along with me. But make sure you can do these on your own, because this is really similar to what you'll see on your tests with different vectors, different numbers, but same idea.